So the next step up from an infinite sequence are so-called infinite series. So to get an infinite series, you just take the terms of an infinite sequence and add them together. Right, the major question we're going to want to answer here is the same one we asked about sequences. Does the series converge? And to answer that, we're going to connect these series back to sequences in a way that will let us leverage the tools that we've already developed. So to do that, we're going to define something called the sequence of partial sums. Now, each term in this sequence is equal to the sum of a finite number of terms from the original series. So S sub 1 is just the first term. S sub 2 is the sum of the first two terms, and so on down to S sub n, which would be the sum of the first n terms. So to find convergence of a series, we just say that the series converges if its sequence of partial sums converges, and that the original sum is equal to the limit of that sequence. That's what we've got here on the second equation line. That's the original sum. We're going to say that that is equal to the limit of the sequence of partial sums. So let's look at an example here. I want to take a look at this infinite series and first see if it converges, and we'll see that it does. And if so, I want to see what value it converges to. So to do this, we don't have a whole lot of tools in our toolbox yet. I'm just going to look at the sequence of partial sums and see what happens. Right, so S1 is just the first term, which is 1/2, 1 over 2 to the first. S sub 2 is 1/2 plus 1/4, 1 over 2 squared, which is 3/4. S sub 3 is S sub 2 plus 1/8, which is 7/8. And now I'm starting to see the pattern. Right, the denominator is 2 to the n, and the numerator is always 1 less than that. So the numerator is going to be 2 to the n minus 1. So now I've got a formula for the nth term of this series. For the nth partial sum. So to talk about convergence of the series, what I want to do is talk about the convergence of that sequence. Right? The limit of the sequence of partial sums is equal to the limit of my formula there. And to see what's going on here, I'm going to simplify this a little bit. I'm going to split the fraction up. I'm going to make it 1 minus 1 over 2 to the n. And now this is something we've seen before. The limit as n approaches infinity of 1 is just 1. And the limit as n approaches infinity of 1 over 2 to the n, that's going to be 0. So the limit of the partial sums, that's S, the sum of the original, the value of the original series. That's equal to the limit on the right-hand side, which is 1. So the answer to my question first is yes, this does converge. And second, the series converges to 1. So we've got a couple of links here. One is to another example lecture where we're going to talk about something called a geometric series, which is kind of a generalization of the series that we looked at on the last page. And the other one is to the next full lecture in the series where we're going to start developing some tools that we can use for determining whether or not a series converges or diverges. And of course, if you like this lecture, please don't forget to click on that like button down below as well.